Our goal in working with truth tables, the whole point of this exercise, is to be able to use truth tables to help us analyze deductive arguments. But when we make deductive arguments, we often have quantified statements among our premises. How can we get those into a truth table? We only can make truth tables for compound statements made up of simple statements, simple sentences. Well, there's a game that we can play where we take a universal statement. This will only work for universal statements. Where we take a universal statement and apply it to some arbitrary thing to make a compound statement. That's called instantiating. So if we want to turn a universal statement into a compound that we can symbolize, we start by instantiating it. We apply it to an arbitrary thing. Now, when we do this, we'll want to refer back to our basic truth tables. Right? We have a basic truth table for and, one for or, one for if then, and one for if and only if. Ultimately, we will want to see if the truth table that we end up with matches one of those. So let's have a go at symbolizing a positive universal statement. All birds can fly. We have the statement, all birds can fly. What would that mean? What is that telling us? Well, it's telling us about two categories, right? The category of birds and the category of flying things. So if we apply this to some arbitrary object, we might be saying our object is in the category of birds, so this thing is a bird. And we might be saying it's in the category of flying things, so we might be saying this thing can fly. And we aren't thinking of any particular thing, we're just considering an arbitrary thing in the universe. But whatever it is we're talking about, statement P is that it's a bird. Statement Q is that it can fly. When we're working with arguments, if there's some specific individual the argument is about, that's what we're going to plug into these categories. Okay. Now let's make a truth table involving P and Q. And to do that, we're going to think about the meaning of the statement, all birds can fly. Here I've started out the truth table for us. We have a P column and a Q column filled in to give us every possible combination of truth values for P and Q. In our first row, we have P is true, Q is also true. That means P being true means we're looking at a bird. Q being true means the thing we're looking at can fly. So this thing is a bird that can fly. If we're looking at something that is a bird that can fly, well, there's nothing there to contradict all birds can fly. So that's just fine. All birds can fly is still true if all of the things we look at are birds that can fly. If P is true and Q is false, well, P is true, we're looking at a bird. Q is false, it can't fly. We're looking at a bird that cannot fly. Well, if I'm holding in my hand a bird that cannot fly, then it's not the case that all birds can fly. Like this bird right here can't. So if we have an arbitrary thing that's a bird that can't fly, that means that all birds can fly is false. What if P is false and Q is true? Well then, P is false means that I'm not looking at a bird. Q is true means that it can fly. Maybe it's an airplane or a butterfly or something. So this thing is not a bird, but it can fly. Well, that doesn't say anything at all about all birds can fly. That can still be true. I can have all sorts of non-birds that can fly, and all birds can fly is still true. P is false and Q is false. Well, that means the thing I'm looking at isn't a bird, and it can't fly. Again, that doesn't tell us anything about whether or not all birds can fly. That's no problem. So the column we get for all birds can fly, when we instantiate it, apply it to a specific thing, is true, false, true, true. Looking back at our basic truth tables, we have, true, false, true, true. That's the column for if P then Q. By matching the truth table, we can symbolize all birds can fly as if P, then Q. How do we understand that? So P is, this thing is a bird. So if something is a bird, then Q. Then is the thing can fly. Right? If something is a bird, then it can fly. All birds can fly. Yeah, that means the same thing, right? So that's how we handle a positive universal. We instantiate it, we apply it to an arbitrary thing, and then we symbolize it as a conditional. Positive universals will end up being conditionals in this form.